Okay, so pretty long question. For each divisor k greater than 1 of n, let ukn be the set x in the multiplicative group of integers mod n such that x is congruent to 1 mod k. And it gives us some examples. U321 is the set 1, 4, 10, 13, 16, 19, and U721 is the set 1 and 8. And we need to list the elements of U420, U520, U530, and U1030. And we need to prove that UKN is a subgroup of UN. And finally, let H be the set of elements that are in the multiplicative group of integers mod 10 such that x mod 3 is equal to 1, and is H a subgroup of U10? Okay, so I'm just going to start by listing out the elements of U20, which are 1, 3, 7, 9, 11, 13, 17, and 19. And so U420 is basically just any number in this list that is congruent to 1 mod 4. So 1 obviously, and 9 is the same as 5, which is the same as 1, so 9, and 13 and 17. So this also means that U520 will be the set 1 and 11. And for U30, same idea applies. We'll get U530 is the set 1 and 11, and U630 is just 1. Okay, so now for the proof, I'm going to use the subgroup criterion, which states that some set H is a subgroup if A, B inverse is in it, whenever A and B are in it. So I'll start by stating that A and B are in UKN, and so this means that A is congruent to 1 mod K, and B is congruent to 1 mod K. And just to note, B congruent to 1 mod K also implies that B inverse is congruent to 1 mod K. And if you don't believe me, I'll work it out on the side. But basically now we can say A times B inverse is congruent to 1 times 1, which is congruent to 1 mod K. So this means that AB inverse is also in UKN whenever A and B are. So by the subgroup criterion, UKN is a subgroup of UN. And now for this last part, if H is any element that is congruent to 1 mod 3, is H a subgroup of U10? So first I guess I'll list out all the elements of U10, which are 1, 3, 7, and 9. And so this means that H will be the set 1 and 7, and this is actually not a subgroup of U10, and this is because 3 is not a divisor of 10. So since it doesn't follow the assumptions of our theorem, then it doesn't apply. And you can also sort of prove this anyways. If we take 7 times 7, which is equal to 49, that's congruent to 9 mod 10, and the element 9 is not in H. It breaks closure, so that's why H is not a subgroup of U10.